This problem shows us a reaction, shows us a system at equilibrium, and what we need to do is figure out if we make these changes, how is that equilibrium going to be shifted? Are we going to shift towards the formation of more products, or are we going to shift towards the formation of more reactants? And to do this, we use Le Chatelier's principle, which tells us that if we have some change to a system, the system will respond to minimize that disturbance or minimize that change. So we can look at all different types of changes and figure out which way the equilibrium will shift, whether it be to the right or towards the left. Now the first two we look at are increasing and decreasing temperature. And in order to do that, we have to know something about the enthalpy of the reaction, our change in enthalpy. Here we have a negative delta H value, which tells us it's an exothermic reaction, which tells us that we can look at heat as if it were a product. So I'm actually going to go over here and write plus heat with my reaction, just as a reminder that I'm treating it like a product because I'm losing energy as this reaction proceeds. So if I increase my temperature, that's the same as adding heat to the reaction, and so what I'm going to see is that's going to drive the reaction towards the left, towards the formation of more reactants. If I decrease my temperature, I can look at that as the same as I'm taking away heat, I'm removing one of those products, and so as a result, that's going to drive the reaction towards the right. Now, knowing that we're doing an increase and a decrease in temperature, we would expect different responses in the way that the reaction shifts towards the left and the right. We can also look at increasing the volume or decreasing the volume, and in order to do that, what we have to worry about is the moles of gas. And so when I look at my reactant side, I look at all my substances are gases, so I can count everything. On the left side, I have 4 moles of gas, and on the right side, I just have 2 moles of gas. And so if I increase the volume, what I'm going to see is that the reaction is going to favor the side that has more moles of gas. We're increasing the volume, it decreases the pressure, but if I re-increase the moles of gas, I'm going to get a shift towards the left side. Likewise, if I decrease the volume without any other changes, I would be increasing the pressure, so the reaction is going to shift to decrease some of that pressure that we've gotten from decreasing the volume. And so I go from 4 moles of gas to 2 moles of gas on the right, and so I'm going to see that it's going to favor the right side and favor the fewer moles of gas. Now note that we always look at the moles of gas here. We never, if we have solids or liquids, we don't include those in those calculations. Okay. Again, we increased the volume, we've decreased the volume, we've done opposite things, we see opposite responses within the reaction. Now I'm going to look at adding nitrogen or hydrogen, and here what I'm looking at is I see that nitrogen and hydrogen are both reactants. And so if I add more reactant, the system goes, wait a minute, we've got too much reactant, I need to get rid of some of that reactant, and the reaction is going to need to shift towards the right to minimize the effect of that added reactant. If I add NH3, it's going to say, wait a minute, now we've got too much NH3, I need to get rid of some of that NH3, and the way it gets rid of that excess NH3 is to shift towards the left, toward the formation of more reactant. We see just the opposite happening when we remove N2 or H2 or remove NH3. If I remove N2 or H2, one of my reactants, I see that I now don't have enough of my N2 or H2 to be at equilibrium, and the reaction will proceed in order to make some more N2 or H2 to make up for that loss, so it will shift towards the left. If I remove NH3, I now don't have enough NH3 to be at equilibrium, so the reaction is going to shift to try to replace some of that lost NH3, so it will shift to the right. The last change we can look at is the addition of argon, which in this case is an inert gas, meaning it doesn't react with any substances in the mixture. Okay? Because of that, it actually has no effect on the equilibrium. And so we will see that it will not shift towards the left or towards the right because the partial pressures of my nitrogen, hydrogen, and NH3 are not affected by the addition of this argon gas. So we can take any reaction and figure out how it will be affected by these different changes. If we had an endothermic reaction where our delta H was greater than 0, had a positive value, then would we see a different effect because of the increase in temperature and decrease of temperature. Likewise, if we have a different reaction with different moles of gas on the reactant and product side, we may see a different shift in that equilibrium as we increase or decrease the volume.